Hello. Yeah. Good morning, everyone. This is Anand here. So, welcome to my channel, AJ Global Institute. AJ Global Institute. Okay. So, in the last class, we have discussed about basic Java introduction, like what is Java, features of Java, what is the template, I mean, structure of Java. First program we have C. Okay. And JDK installation we have done successfully. We downloaded, we installed, and finally we set path successfully. Okay. Now, up to date, I think you all are okay. Now we are going to discuss one new topic called JDK, JRE, and JVM. Okay, this is very fundamental for the Java. Even if you are non-IT background also, you can understand this topic. If you are okay, if you are good at this topic, you can learn any topic easily. I mean, if you are good at this topic, you can learn Python, you can learn .NET, you can learn any other programming language easily. Okay, so this topic is very important, and deeply we are going to enter into the Java now onwards. Okay, yeah. So first, what is my heading here? Introduction to Java platform. Introduction to Java platform. So already I explained to Java is a programming language and platform independent. Platform independent. Okay. Java follows the principle write once, run anywhere. You all know very well. It follows the principle called ORA principle. ORA stands for write once, so run anywhere. What is that meaning? Write Java code one time, run it on Windows like Linux or Mac or mobile, etc. Once you write the code, you can run the code on Windows operating system or Linux operating system or Mac OS or mobile also. You can execute the same code without doing any kind of modification. We successfully complete up. You all understand about this. Write once, run anywhere. Every time. No need to change the modification for your different operating system. Take human. My parents one time given my name Anand. So the Anand is common for all the people. Everyone can call me Anand only. My parents only one time name given full. Okay. So remaining all the people am for my neighbors, for my colleagues, for my friends, for my, any kind of people, I am only Anand. I am not different name for different people. Got my point? Huh? Same thing here. Write once, run any run on any kind of operating system. That principle, that process is called a ORA process. Okay, ORA process. This is possible because of JDK, JRE, JVM. This is only possible because of Java Development Kit, Java Runtime Environment, Java Virtual Machine. Okay, these are the backbone of Java. Which are the backbone of Java here? JDK, JRE, and JVM are the backbone of Java. So let me explain picture about Java. Now we'll see the Java execution flow. Java execution flow. So first we'll write one Java file where we write Java program and we save the document or we save that file with a .java extension. Okay, I will show you. Don't worry. After this is called what actually this is a source file. After that, we need to compile the Java file using which command? Java C command. Okay, which command? Java C. This is the first step and this is the second step. After that, in the third step, we'll write a when we compile the Java file, dot class file will be generated. First Java source file, then we'll compile the program, then finally one byte code means one dot class file will be generated. Finally, this byte code or dot class Java file will execute by JVM. Okay, who will execute this? JVM. This is bytecode. Okay, this bytecode can be, for example, I have created this bytecode on my Windows. The same bytecode can be executed on Linux and Mac OS without doing any kind of modification with the help of JVM. Got it? Huh? Then what the JVM will do? It will convert machine understandable code. Okay, finally it will produce the output. We'll see the output. This is the internal process. Why? Because Java is a human understandable language. We are writing the Java in general English. Okay, this is the internal process. But the computer can understand what are zeros and ones. Who will who is taking care of this? JVM. JVM is what? Translator. Okay, it will take care of translator. Okay, the JVM contains interpreter and a JIT compiler. I will explain those topics in my further further topics. Okay, step by step process. Step one. First, what will the same procedure I will show you now. Okay, with example. File program in .java file. Okay, so we need to compile. What the compiler will do? Compiler convert source code into bytecode. Bytecode in the sense what here? Dot class file will be produced. Dot class file will be executed. When we compile using Java C, then automatically dot class file will be generated. So bytecode stored in where? Dot class file. Yes, JVM reads bytecode. JVM reads bytecode and JVM converts bytecode into machine code. Okay, finally, mission is what? Computer understandable code. Who convert that? JVM. Who will take care of that? JVM will take care to convert that, okay, bytecode to machine understandable code. Finally, program will be executed. Once the machine understands, then only the program will be executed. Otherwise, we won't see any kind of output. The simple funda. There is a, okay, I know Telugu, but two people are there. One person knows Telugu, one person knows English. I know only Telugu. The person one knows only Telugu, and the person two knows only English. I don't know English. This person two don't know Telugu. So how we can communicate with each other? One third person required who knows both English and who knows English and Hindi. That third person will be required. Okay, this is person one. You got my point? This person. Okay. Um, this person knows what here? The same thing. This one. Yeah, here also. The person who knows both the languages, like what? Sorry. Yes. Okay. This person knows only English. Telugu. Try to understand the concept. This person knows only English. This person knows only Telugu. This person knows only. Assume this is my Java code. And this is my computer. Okay. This is my Java code. This computer. Java code is in pure general English. Okay. It is in English. But computers knows what here? Sorry. Computer knows only zeros and ones. Now, one third person should be required between these two persons. Who is that person? Third person. This what the third person will do here. The third person will take care of this. Okay, this is the third person, and okay, this is the JVM compiler. Okay. Yeah. So this is the JVM. Okay. What is this translator? It will take Telugu from person one. Assume this is the person one, and this is what here person two, and this is what here third person. Okay. What here person one will take the input from the input. Okay. Sorry. Person one will take the input from person 3 will take the input from person 1. The same thing will translate to the person 2. And it will take the reply from person 2 and it will give the output. What my point? It will convert the person JVM will take the input from the person 1 and it will understand, it will translate into bytecode. It will generate the bytecode, like it will generate what here? Bytecode. Okay. This bytecode will execute a different kind of operating system. Person 2, person 3, this is common. For person 4, like this. You understand, right? Telugu. Okay. Next, Telugu, English. JVM is what here? It's a translator. With the help of JIT compiler and with the help of interpreter, okay, the translator will take the input from the Telugu and that will be updated to the English, and the same time take the update from the English P2 and update to the P1 person. Finally, we are getting the output. Okay, this is the process. Try to understand this. Okay, this is the process. Okay, now JVM converts bytecode into machine understanding. This is okay. Understood, right? Finally, we'll see the output here. What my point up to here clear, right? No doubts at all, I think. So Java follows ORAC principle. Okay, in principle, we are discussing about the execution flow. Java source file will be compiled by the JVM. It will be, when compiled, automatically bytecode will be generated. Dot class file will be generated. I will show you the practical. Okay, JVM execute that bytecode on any kind of mission. Mission 1, mission 2, like Windows operating system, in Windows, Linux, and Mac OS. Okay, this is the process. Now, come to the second point, JDK. Now, tell me, what do you mean by JDK? If you have still doubt, I will show you. Let me execute one small program. I will show you. Let me open the notepad. Otherwise, let me open the command prompt. Okay. So let me take where see the users under PC. Notepad new.java. New is what? File name. Anything you can type. Otherwise, I want to write here what? Execution. Execution.java. Execution.java. Yes. Now let me open this file. Let me write a small program here. Class sample. Yes. Public static void main public static void main. Yes, close the class also. We all know this, right? Previously we discussed. Let me write this thing here. GS. Okay. Let me write one more file, polysystem dot out dot in line shell. Okay. Let me write this thing. Let me write this code. Hello, welcome to the file Java classes. Right? Yeah. When after saving file, if I want to execute this, how can I execute? First I need to compile using what? Java C command. Okay, this is my normal Java source file. Java source file. What is the file name here? Execution.java. This is general Java file. Which one? Would understand? This is what? Just one file. While programming, I need to write the program and to save that file with the .java extension. Okay. I need to compile. In second step, compiler will convert. How to compile? Using Java C command. Which command I should use? Java C command. Java C, this is the syntax we need to follow. What is the file name? Execution dot Java. This is my file name. File name not found. File not found. So what is this file name? Yes. Yeah. Here I can see. What is the file name? Notepad execution dot Java. Just remove the notepad and the Java C. Enough. No errors. Okay. Just execute enough. Let me go to this location. C drive users PC and Java C. Let me go to that location here now. Uh, Let me go to that location. Where is this C drive? Yeah, users PC. Where is the file name? Execution file. This is my file name here. Execution is my file name. Execution. Where I can find. Let me open. Yes. See. Let me check with date 2024, 2000. C users PC. Users. Let me refresh it. Let me open this. Yes. Yeah, codex. April 4th. Yes. Yeah, P2. This is was stored somewhere. It's this file only. This file only. Otherwise, let me tell you very simple process. Like this. We can search, but it is by default it is storing somewhere. We can search in this way also. Yeah. Let me do one thing. Very simple. Take Anand file. So let me create my new file. Yeah, let me take the new folder here under Java. Under this is my folder name here. Inside this folder name, I want to save this file. Which file? I want to save there. Inside that folder, I would like to save. Inside folder, I would like to. Where is my folder here? This PC, A drive, and Anand. Inside Anand is my folder name here. Anand Java, right? Is the folder name here. Let me open this D drive online Java. Okay, go to this. I'll go to this. I'll save as D drive. Where is this? This PC D drive, and let me check slowly. Yes, stop. Online Java. Let me save this file name called test. Uh, this is a file name exe 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 execution. Okay, let me compile the file once again. Java C, sorry for the delay. Java C, what is my file name here? Again, what is the file name here? What is the file name here? What is this? Local disk uh, online Java batch, right? So local disk online Java. The executi execution file 125 pm generated. Okay, the one source file generated. This is Java source file. Now let me compile the program now. Java C executi version dot Java. I'm compiling my program. No errors. Now just I compile my program. So when I compile Java file, automatically what happens here? One source file, one bytecode will be generated. Let me refresh. Okay, let me open this also again. What is the issue here? Is not able to identify because okay. Let me take here. Let me take one notepad here. Let me take the notepad. Let me save the file. Here I can save that file. Okay. That's good. Dot. What is my file name here? That's dot Java. Save. Okay. Just add this bundle code. Insert this. Don't get confused. Nothing is there. I'm not doing anything. Just to save this file. Okay. Now, where is my first? I need to switch to the D drive. Go to the D drive. Online PD. This was online Java. Java. Now Java C. Here. Dot Java. That's the Java. Now let me go to that place. Let's see. No problem. Now see. What is my file name here? Text dot. This is my Java source file. When I compile my program, sample.class file created here. This is my source file. This is my dot class file. Okay, na? The 127 PM I have created one source file. I compile that whole file. So that converted into dot class file. Which file? This is the byte file, byte code. This is sample.class. This is my byte code. This byte code can be executed on any kind of operating system. Any kind of what here? Operating system. Got my point, right? So I compile. When I compile, bytecode will be generated. Dot class file will be generated. Okay. So machine code that will be that make that it next to step JV will take care of it. Understood? This is what. So this is complete step by step processor. You understand, guys? First, so let me explain first what I'm doing. Nothing I'm doing. Just I'm showing what is Java. Java is a platform independent. So when we execute Java, okay, when we write Java file, okay, we need to save the file with dot Java file, dot Java file extension, okay. And after writing that, we need to compile the program using Java C command. How to? What is the syntax? What is the syntax to compile the program? Java C, Java C space file name dot Java. This is the compilation syntax. Okay, need to remember that. When we compile, automatically bytecode will be generated. Means dot class file will be generated. That dot class file can be executed any kind of thing. That's enough. Okay. And next step, we are going to see complete scenario about the JDK. What is JDK? Very important, very fundamental thing, guys. What is JDK? JDK stands for what here? Java development. Now onwards we'll go a little bit speed. Okay. JDK stands for what here? Java Development Kit. So JDK is used for what? What is the purpose of JDK? Developing Java applications, writing Java programs, compiling Java code, running Java programs. Keep these 4 points. Keep these 4 points in mind. Keep these 4 points in mind. What is the purpose of JDK? What is the full form of JDK? JDK is a Java Development Kit. It is used for developing Java applications, writing Java programs, compiling Java code, next running Java programs. Okay. This is the main pull. JDK is what here? Main pull. I will show you practically. JDK is what here? Main pull. Okay. Yes. So JDK is a software package that provides tools required to develop Java applications. What is JDK here? JDK is a software package that provides tools. Which what that provides? It provides some kind of tools. Okay, what are the tools required to develop an application? I will show you. You will get very much clarity about the JDK. JDK stands for what is Java Development Kit. What it will provide? It's a software package. It is used to provide some kind of software required tools to develop an application. So what the JDK contains here? JDK contains JRE. JRE stands for what here? Java Runtime Environment. I will explain. That JRE contains again JVM. JDK inside JRE, JRE inside JVM. These three are the important. Only three things. What are those? JDK inside JRE, JDK inside JRE, JRE inside JVM. I will show you diagrammatically. Don't worry. Okay. JDK contains JRE, JRE inside JVM. JDK contains what? Java C. JDK contains what? Java. JDK contains what? Java document. JDK contains what? Java debugger. Development tools. Main components of JDK. Now we'll see what are the main components. This is the tool and this is the purpose. Main components of JDK. Okay. Main component what here? Main component of JDK. So Java C. What is the purpose of Java C? So the Java C existed inside JDK component. JDK. Okay. So what is the purpose of Java C? Java C is used to compile Java program. What the Java C will do? It will compile the Java code. Next, what Java will do? Java runs Java programs. What Java document will do? Java DOC will do? Generates documentation. What debugger will do? It finds errors. What jar will do? Packages files. I will explain. You will get very much clarity. Don't worry. So what Java C command will do? It compiles Java code using Java C file name dot Java. What Java will do? It runs Java program. Okay, let me show you. It runs Java program. Compilation is over now. Next, what we should do? We need to run the Java. How to run Java? Java space sample. What is my class name? What is my class name here? What is my class name? Okay. This is my class. While compiling the program, we should give the file name. Keep that point. While compiling the program, compiling the Java program, give file. But when we are running the program means executing the program, then give class name. Then give what here? Class. For example, this is my file name. This is my class name. File name is different, class name is different. Okay, what is my file name here? What is my file name? Text is my file name. What is my class name? Sample is my class name. Okay, so when we are compiling the program, give the file name. But when we are running the program or executing the program, give a class name. Chalo, welcome to my Java classes. This is what. Are you clear, right? I hope you understand, guys. Okay. Okay. These are focus. Okay. Next, Java C, Java document is used to generate documentation. Debugger is used to find error. We are finding the errors because of with the help of debugger. Java debugger will be there. So we are with the help of the debugger, we are finding the errors. Next to jar. Jar is a packages files. Jar files very most important. I will explain in my further classes. Okay. Now don't get confused, guys. We'll see what is the real-time example for JDK. Just imagine your kitchen. Okay, kitchen, complete kitchen. JDK is nothing but your complete kitchen. Complete kitchen. Okay, that this is kitchen pool. That kitchen contains what here? It contains stove, it contains gas, it contains vessels, it contains ingredients. Stove, gas, vessels, and ingredients. Then, with the help of these all, we can prepare a food. We can cook food. Okay. Similarly, JDK contains what here? All tools to develop Java program. Got my point? Let me explain this program. By seeing this, you will go. This blue color box indicates what here? This blue color box indicates JDK. Java development kit. Java development is blue color. Inside blue color, we have one more green color box is there. Green color box is there. That indicates JRE. But JRE inside where? JDK. So JDK inside JRE is there. So what is the full form of JRE? Java Runtime Environment. Now we are going to discuss about Java Runtime Environment. The second one. Big pool is over. Big pool, blue color line, blue color box is over. Now we are going to enter JRE. JRE stands for what here? Java Runtime Environment. JRE is used to run Java applications. It provides environment for execution. It provides what here? Environment for execution. Okay, but cannot develop programs. Java JRE purpose is different. JDK is used to develop an application, but JRE is used to only execution purpose. It provides some environment to the execution purpose. Okay, the JRE doesn't contains what here? No compiler, but JRE provides libraries and runtimes. Some libraries in the sense what here? Predefined classes, predefined packages. It contains that much only, and it provides some kind of environment required to run Java application. I will show you. Okay. That JRE contains what here? JRE contains JVM, core libraries, and supporting files. JRE contains what here? JVM, inside where? JRE. And that JRE contains what here? Core libraries, required built-in packages, built-in classes required. Then supporting files will be required. Okay, so now let me explain components of JRE. What are the components of JRE available? So component name and the purpose. What is the purpose? Here component name mentioned and here you can understand the purpose of the particular component. Okay, so JVM. Okay, what is the purpose of JVM? Executes bytes code. Already I shown you example. Okay, executes byte code. And libraries. Libraries means what? A predefined classes and some kind of packages. Next, runtime files. Runtime files means what? A support execution. Support to execution. Now, so example is what here? End user. End user. End user means a bank employee uses banking software. They only run the application. How to understand the JRE now? How to understand the JRE? What is the purpose? How much it will involves to develop an application? We are going to see now. Okay. A bank employee uses banking software. He doesn't develop. He doesn't involve developing the application. Just he will enjoy. He will enjoy the feature. He will use the feature. That's it. They only run the application. They want to write a code. They do not write any kind of code here. What it is? Example, JRE like what? Television. One more example. Let me explain one. JRE like what here? Television. TV. Okay. In TV, what we can do, just we can watch the programs, but we want to create channels. Channel created by JDK. But what JRE doing here, just it can enjoy the progress, but it can't create any kind of channels. Okay, so how to understand that into the coding? JRE can run Java programs, but cannot develop them. What JRE will do, it can run the programs, it can enjoy the feature, but it won't involve in developing. So you understand. Let me explain that once again. Okay, let me explain that. Sure. Yes. So here JDK is over. JRE. JRE contains what here? JVM. So kitchen set example. Chef tools contains JDK. Kitchen setup contains what here? JRE. Cooking machine contains JVM. Output Java and program execution. This is what here. With the help of this. Okay. Already you know vessels, stove, gas and contains the. Okay. But what the JRE will contain? What are the things required for that? It will have the food. That's it. Next finally JVM. What is JVM here? JVM stands for Java Virtual Machine. JVM is the heart of the Java. This is very important point. JVM is the heart of Java. It executes bytecode, converts bytecode into machine code, provides platform independence. Okay. So JVM is virtual machine that converts bytecode into machine code and executes. Virtual machine that converts what here bytecode generated, bytecode in the sense dot class file. Who will execute that? JVM. JVM will take care of it. Already I explained very well. Bytecode dot class file. JVM working day. Only this is JVM working day. When we use Java C command, Java C space file name dot Java, one bytecode will be generated. One dot class file will be generated. I already showed you. Okay, JVM reads code properly and converts to machine code. What my pattern? So now let me explain why JVM is so important here. Why we are calling JVM is heart of the Java, heart of the Java program. What is the importance of JVM? We'll see now. Because Windows machine understand only Windows machine. Windows operating system understand only Windows operating system code. Linux machine understands only Linux machine code. Okay, if I write any program on Windows, okay, I can execute that program only on Windows. I can't execute the same code on any kind of other operating systems like Mac OS or Linux. That is possible. That is not possible if there is no JVM. Okay. Okay. So if I want to execute the same code in any kind of like Linux or Mac OS, I need to prepare complete code. But here that is not happening. Here what happening actually, we are writing the code in Windows. The same code we are executing that in Linux. We are writing code on Windows. The same code we are executing on Linux without doing any kind of modification. Okay. So here JVM act as a mediator. So it is acting as a mediator, translator. So platform independent. Same bytecode can be executed on Windows. Same bytecode can be executed on Linux. Same bytecode can be executed on macOS with the help of JVM. What did I imagine? English teacher speaks what here? English only. English teacher speaks English. Telugu student understand Telugu. Hindi student understand Hindi. Then what here? Translator converts language. Similarly, JVM converts bytecode into machine. Already I explained. JVM is what here? Mediator. Okay. So internal architecture we'll see. JVM architecture diagram. Class loader. Okay. Bytecode verifier. When dark class file will be generated automatically, class loader will be involved. Then bytecode verifier. It will verify the bytecode. Then runtime. So this is very important topic guys, runtime. So memory segments. So heap, we have three kind of memories: heap area, stack area, and a method area. These all are existed inside where JVM only. Who will take care of these memory segments? Java virtual machine. Okay, execution engine. And this JVM contains interpreter, JIT compiler. The JVM contains what here? Two I's. What are those? Interpreter and a JIT compiler and the compiler and the interpreter. Interpreter, what interpreter will do? It will compiles or it will translate any kind of code line by line. But what compiler will do? Compiler will compiles 1,000 lines of code at a time. There is a difference. Keep in mind. So making. So components of JVM. Class load. What is class loader? What is the purpose? It will class loader loads dark class files into memory. I will show you. Don't worry. Example: when you run Java space tester, class loader loads test.class. Okay. Yes. Bytecode verify checks security, correctness, and the illegal code. Is there any kind of security is missing or code is correct or not? And is there any kind of illegal code available? It will check. Who will take care of this? Bytecode verify. Okay. These all exist inside where JVM architecture. Okay. So class loader, bytecode verifier. What the class loader will do? It will loads dark class files into memory. It will send dark class files into the memory segments. Who will send that? Class loader. Then what bytecode verifier will do? It will check security. It will check correctness. It will check illegal code. These all things. So prevents harmful code execution. Who will take care of this? Bytecode verifier. These are the security codes. Okay. And runtime memory area. JVM allocates memory, you know that. JVM allocates what here finally memory. Now let me explain very small thing, types of memory segments. So memory and purpose. Heap memory is there. Already I explained here heap memory. These are the memory segments. Okay, heap memory, stack memory, and method area. Three types of memories keep in mind. Heap memory, stack memory, and method area. So here, heap memory means what here? What heap memory will do? It stores only objects. Heap memory will store the object. It is very important question, and the interviews frequently asked questions in interviews. The most of the students will get confused here. Okay, even if you are the fresher or even if you are the 4 years, 5 years of experience, you should know. The most of us doing even developers don't know this purpose. They are doing work, but they don't know where the objects are exactly going and storing. Okay, so be careful. Even if you want to switch your job from non-IT to IT background or any kind of freshers to, if you want to switch to some company by putting some kind of by adding some kind of additional experience, so these kind of things will be highlighted. So what are those? Heap memory. So heap is a what is a heap memory? What the heap memory will do? It will store the objects. What the stack memory will do? It will store the method calls. I will show you. Don't worry. What the method area? Class information. Method area contains class information. See, let me explain one by one with example. So heap memory means what a student, for example, how to create an object, class name. Next, object. This is object. S is an object. Object name can be given anything, not only S, anything you can give. Or any plus, it's use a different one. Obj. What is my class name? This is class name syntax. After class name, object name is equal to new is a keyword. New is a keyword, then again constructor. Class name, object name, new is a keyword, and a constructor finally. Those, what is the object name here? Object. These objects will be stored in where? Heap memory. This is my object. This object stored where here? Heap memory. Okay. Heap memory. This is heap memory. For example, these objects will be stored in where? Heap memory. This is assume this is what object. Assume this is what here my object. Object name. Object. Okay, object. Okay, that object stored where here? What is my object name? Object here. So, okay, somewhere here. Obj is my object. Okay, understood? You got my point, right? Object stored in heap memory. Stack memory example. Okay. Int x is equal to 10. Int is a data type, x is a variable name, and 10 is a value. So this reference variable will be stored where? Reference variable will be stored in stack memory. Second memory is what here? Stack memory. Object stored in heap memory, reference variables. What is reference variable here? X is my reference variable. So all variables will be stored in stack memory in interview point of view. And local variables stored in stack memory. Okay, local variables stored in where? Stack variable. Execution executes code. Okay. Next we'll see the execution process. Interpreter and a JIT compiler. What the interpreter will do, it reads code line by line. At a time, it won't read the code at a time, all the lines. So if there is a 10 chocolates, what the interpreter will do, it will eat first one chocolate, then second chocolate, then third, fourth, fifth, sixth, seventh, eighth. One chocolate after one chocolate it will do. So the process will be slow. But what the JIT compiler just in time? What is the full form of JIT? Just in time. Compiler will do here. It converts repeated code into native machine code. If there is a 10 chocolates, it will eat at a time all the chocolates first. It will eat all the 10 chocolates at a time, then will eat. It will eat. Okay, that is only the interpreter and the compiler. Compiler executes line by line code. Okay, it will. If there is any mistake, it will give the mistake. But compiler will do what here? It will first it will eat the 10 chocolate, then replay it. Okay, fast execution. Compiler interpreter is a slow execution. Compiler is what? Fast execution. Example of interpreter. For example, teacher translate every sentence separately. So if there is a 10 sentences, the teacher first she will to pick one sentence and she will translate that and she will teach separately. It might be clear, but it will take lot of time. Okay, so this process is called very slow. But what the JIT compiler will do here actually, teacher memorize repeated sentences. Okay, she can she can memorize repeated sentence easily. Got my point? Hmm. What are the repeated sentences are there? So she will memorize it. That's it. Okay, so automatically the work will be fast here. Next we come to the garbage collector. So what the garbage collector will do, it will remove all the unused objects at a time. Okay, see, student S is equal to new student. S is equal, S point to null. Nothing. Null means what here? Nothing. Nothing. I am pointing to this S object. So what it will do? It will delete. By default, the S will be removed from the memory pool, heap memory. So object will be stored in which memory location? Heap memory. If you are not assigning any value to that object, automatically garbage collector will remove it. Unused objects. Now here in this scenario, S is unused. I am not pointing anything to this S object. So it is pointing to null. Null nothing but zero. Nothing. Objects becomes unused. This kind of situation. So garbage collector removes it by default without your intention, without taking any kind of permission from your end. By default, it will be removed from heap memory okay, with the help of garbage collector. Okay, so next garbage collector works like what here? Municipal cleaning service, removes waste automatically. Municipal workers, or by default these people will come regularly and remove all the dust from your neighbor places. Okay, so that's now finally let me explain difference between JDK, JRE and JVM. Comparison. Okay, full form. JDK stands for Java Development Kit. JRE stands for what here? Java Runtime Environment. JVM stands for Java Virtual Machine. Purpose is what here? It develops and run the program. But what JRE will do? It only runs. It won't develop. It won't involve in. It's like what? Television. JDK involves creating the channels, but JRE involves only watching the TV. Okay, JVM executes bytecode. Okay, it will, what the JVM will do, it will serves us. Okay, serve us. It's like what here, um for example, uh, TV created, manufactured. So if you ordered something through Amazon, so if you want to, who will bring that? Your JVM one service, or it is like what here, remote. Your remote is what here, JVM. Okay, with the help of that remote, you can watch the movie. Right? That's it. Contains what, JRE plus tools. The JRE contains only JVM and libraries. The JVM contains what here? Execution bytecode there and execution engine here. Okay. So that JDK contains compiler. Yes, JDK contains what here? Compiler, but JRE doesn't compiler any kind of. JRE doesn't compiler, doesn't contains compiler. JVM also. Okay. Development. Yes, JRE doesn't involve. JRE JVM. Execution with in three phases possible. Execution possible with the JDK, execution is possible with the JRE and JVM. Easy hierarchy. JDK contains JRE, JRE contains JVM. So inside JDK, JRE and JVM. Step by step Java execution process. The Java program, run program. This is, see, first test.java is my file name. For human readable code, this is human readable code. In step 2, what will compile the program using command called javac space test dot. This is my file name. When we are compiling the program, we should give this file name. But when we are running the program, we should use when running the program, we should use this command java space test. Compiling the program, file name. Running the program, class. JVM executes this bytecode. When we compiling this program, compiler creates what here? Dart class file. That file name is called a bytecode. This bytecode executes by JVM. Okay. Then Java space file name. JVM converts bytecode into machine code. Output displayed here. Hello Java. Got it? All this, compiler creates bytecode. JVM available for every operating system. Got it? Same bytecode runs everywhere. Got my pointer? Mobile charger example. Phone charger, phone charger plug. Okay, plug change. Phone charger plug changes by country. Changes by what year? Country. Phone charger plug changes by country. But phone remains same or not? Your phone is same, but phone charger plug changes by country. Charger in here, if I'm using 2 pins, but if I go to China, they might be used 3 pins. 3 pin slot. Okay, like that. Bytecode remains same. JVM changes based on OS. That's it. Okay. This is my complete today, successfully completed JDK, JRE and JVM. Okay. Thank you guys. Thank you for watching my channel, and please subscribe my channel and share, and like. If you like my channel, if you like my effort, please like the channel. Okay. You are if you like my channel, then automatically it will make me some happy, and it will give me some boosting to upload many number of videos. Thank you all.